Okay, guys, so we're going to still be doing stuff on a polar grid, but we're converting. So if I have a polar point, I need to be able to convert it to a coordinate grid, and vice versa. If I have a coordinate grid point, I need to be able to convert it to polar. So here's how we're going to do these. For an x coordinate, it is going to be the r value times cosine of theta. And that makes perfect sense because cosine's an x coordinate on the unit circle. Your y value is going to be r times the sine value of that theta. All right, if I have a rectangular and I want to go to polar, the r value, remember the r value is like a radius, and it was derived from the Pythagorean theorem. So the r value is going to be the square root of x squared plus y squared. And we're going to get tangent of theta because that's going to tell us what the angle is. And remember, tangent is sine over cosine or y over x. And then both of these are super easy, guys. They really are. But to make this box right here even more easy, quadrants are super important. For sure, if you want to keep these questions on a low level, then quadrants are your buddies. All right, so let's get started. We're going to do a few examples of converting from polar to rectangular, then from rectangular to polar. So let's go ahead and focus on the first part. All right, so to convert from polar to rectangular, remember you need an x coordinate and you need a y coordinate because that's a coordinate grid. Remember your x, it's off my screen, but at the top of your paper, it's r cosine theta. The r value in problem 1 is -8. So x is going to equal -8 times the cosine value for 5 pi over 3. And you all should know that. What is the cosine value for 5 pi over 3? 1/2. Perfect. Great job. Actually, it's positive. I accidentally wrote negative, but it is positive because it's in the fourth quadrant. And x's are positive in the fourth quadrant. All right. Look, we have an x value. The x value is -4. All right, now let's work on the y's. Remember the y's are r cosine theta. So it is going to be negative. Ooh, that's not right. That should say sine. I'm sorry. Make sure yours says sine. So that's going to be -8 times the sine value, the other part of that ordered pair. And that one is negative. It's √3 over 2. All right, so we are going to have a negative times a negative. This is going to be a positive value. And 8 divided by that 2 is going to be a 4. So the y coordinate's 4√3. So number 1 converted to rectangular form is going to be -4, +4 √3. All right, let's try it again. Next one. All right, polar form. So we're going to focus on x. X is going to equal r cosine theta. So x is going to be 2 times the cosine value of 3 pi over 2. Remember 3 pi over 2 is at the bottom of the unit circle? And it's stuck right on the x-axis, so that's going to be times 0. What's the sine value of 3 pi over 2? Yes, -1. Good. Okay, awesome. So this is going to turn into 0, -2. All right, one more for this kind. We are going to convert 0 to rectangular form. So that 0 stands for 0 degrees. That's the beginning of the unit circle, y'all. So here we go. X is going to be 6 times, what's the cosine value for 0 degrees? Is 1. What's the sine value? Yes, that is correct. So it kind of looks like it's the same, but it's really not the same. Remember, this is spaces away from the pole and radians. And we converted it to a coordinate of 6 and then 0 on the y-axis. Right? Okay, so that was converting to rectangular form. Now let's convert to polar form. Remember, for polar form, you might have more than one answer. That's why quadrants are so important. Okay, speaking of quadrants, let's just identify what quadrant each one of these are in before we even start working. Y'all, what quadrant is 1, -1 in? Good. Let's write Q4. Let's not forget. Quadrant 4. What about number 5? All right, so this is not in a quadrant, but what axis is it on? It's on the x-axis. Is it on the positive side of the x-axis or the negative side? Okay, that helps us. So let's write positive x-axis. And then what about number 7? What are we going to write? Negative y, yes. You write this stuff down, and these questions are going to be so easy for you. All right? Okay, so first things first, we need to find r. And remember, to find r, it's a square root. And it's going to be x squared plus y squared. So that's just going to be 1 times 1, or I'm sorry, 1 plus 1. So the r value is going to be the square root of 2. All right, now let's talk about tangent. So remember, tangent is y divided by x. Y is -1, x is +1. Okay, so tangent is -1. Through all those unit circle drills, you should know what radians give you 1s for tangent. What's the denominator of the radians that give you a 1? 4, very good, very good. So it is 4. Which fourths give you negative? Which fourths is in the second quadrant? 3 pi over 4. And then y'all told me the fourth quadrant, right? What's the fourth quadrant? 7 pi over 4. All right, that is correct. However, only one of them is the right answer. The 7 pi over 4. That's right. That's why quadrants are so important on this. All right, so in polar form, we're going to write the square root of 2 and then 7 pi over 4. Very good. All right, here we are with number 5. Let's go ahead and start finding r. So we're going to square -3 and we're going to square +3. They're both 9s. This is going to be 9 plus 9. It's going to be the square root of 18, but guys, you got to take out a perfect. What does that simplify to? Square root of 3, 2, or 3 square root 2. You guys said it right. All right, here we go with tangent. So again, it's going to be y divided by x. So this is going to be +3 divided by a -3. Look, we got -1 again. Yes, why is it 3 pi over 4 for this one? Quadrant 2, that is correct. All right. So 3 root 2 And this one is for sure 3 pi over 4. Good. All right, problem number 6, R value. Okay, so look, for problem number 6, y'all, it's going to be 3.2 squared plus 0. So under here, it's going to be just 3.2 squared. What's the square root of 3.2 squared? Right, that's right. Let's write 3.2. All right, on to the tangent. All right, tangent's going to be different though. Let's see. Tangent is going to be 0 over 3.2, and that's okay. We're going to have a tangent value of 0. Where do you get 0 for tangent? On the sides or the top and bottom? One of them. It's the sides. It's the sides. Very good. So the left side is pi. The right side is 0 pi and 2 pi, but we exclude 2 pi. Like we're not including that in our domain. Yes, you guys are correct. 0 pi is the answer because that's on the positive side of the x-axis. Good job. And you guys don't have to put the pi symbol, but I do put the pi symbol because I want everybody to know that I'm talking about a polar coordinate. If you notice up here, in the book or on paper, this doesn't have the pi symbol, and that's okay. You don't have to, but Miss Harrington's going to write it. Okay, already on the last one, y'all. All right, here we go. Let's go ahead and find the R value. All right, look, so this is going to be 0 plus 64. It's going to be the root of 64. Now, look, we are not solving an equation. We're plugging in a formula that already had the square root symbol there. So when you take the root, it's always positive. So even though that was a -8, doesn't matter because we're taking the positive root every time. So the R value is plain 8. All right, here we got a tangent. Ooh, tangent is -8 over 0, which is undefined. There's only 2 places where you get undefined for a tangent. What are they? The top and the bottom. The top and the bottom. So it's going to be pi over 2 or 3 pi over 2. Which one do you want?
3 pi over 2.
For sure, because that's where it's negative. Good job. See, not too bad. That is correct. So that's how you guys do that. Do you have any questions on anything?